guys, Shane here. So I'm here with Dan, and I'm here at you're at Slice Engineering here.
Yeah.
So tell me, what is this about? What are you guys doing here?
So Slice Engineering, we just launched our company at ERRF a few months ago. So this is our second show. We're really excited to be here. But basically, our whole concept is we want to kind of push the envelope in terms of engineering and innovation of what's available in the 3D printing space right now. So our big thing, our kind of premier product is a hot end. And our hot end is called the Mosquito. We got a little Mosquito logo here. I don't know if that's going to show up in the shot, but we've got standard versions and high flow versions. But basically what we've done is we've isolated the hot section from the cold section by using very thin walled tubes to change the amount of cross-sectional area between the hot section and the cold section. So by reducing that, we've got about 15% the cross-sectional area of what would normally be in a threaded heat break. By reducing that cross-sectional area, you don't allow heat conduction from the hot section into the cold section.
Yeah, and basically, as you said to me, you're also eliminating everything being on that throat.
Right.
Because everything's there. Right now, the throat is totally separate from the actual structural part of the hot end.
Exactly. Yeah, exactly. So, I mean, whenever you're making something do multi-purpose, it's going to compromise somewhere, right? So we're trying not to compromise. The heat break isn't compromising, and the structure's not compromising. These are very rigid, made in the USA. You know, some really high-tech machining. We're actually getting the guys that are machining this for us are usually make medical devices, so they're a top-notch shop. So anyhow, so we're trying to isolate everything that's supposed to do its job and do its job really, really well.
So on this, do we require? So it's got this big open area. Do we need an active cooling fan on this anymore?
So yeah, you do need a fan. We do provide a 25mm tiny fan on here. We actually did most of our testing without a fan, but PLA is so gummy and it likes to stick to stainless. So PLA kind of gave us a couple problems, so we threw a fan on there. But we supply a fan with it, and we've got 5, 12, or 24 volt depending on what your system requires. Yeah.
So it's the same company that's making your throat, it's making the structure. This all the same companies doing that?
No. So we've got multiple suppliers. So we're getting the fans from different places, the heater cartridges from different places, but all the machining is done here in the U.S.
Okay.
Yeah.
And let's talk a little bit of power. So you were saying these are pretty high power.
Right.
So how high are we looking for the Mosquito, and that's the other one was called the
Mosquito Magnum.
Magnum.
Yeah.
All right. So how much power are we looking for those heaters?
So you can use a regular heater that's already on your printer if you want to.
So a standard 40 watt.
Standard 40 watt, or even 30 watt, or 20 watt, whatever you've got. But we've got some higher power stuff. We've got 50 watt cartridges, both 24 volt and 12 volt. We're looking at 60s that we'll probably have eventually. So with those, we've tested these guys up to over 500 degrees Celsius.
Wow, I mean that's higher than any one I've seen out there.
Right.
I mean, Microswiss E3D, I've never seen anything that high before.
Right. So any thermoplastic will melt below 500 degrees Celsius.
Yes.
So you can print Ultra, Peak, whatever. And obviously there's other issues when you look at Peak, like layer adhesion. You got to have a heated bed, all those things, details. But the point is we can melt that plastic. Yeah, and we can extrude it. So and even at those high temperatures, your heat sink is still going to stay cool. You're not going to melt. So in that test where we ran it past 500 degrees Celsius, the idea was kind of, what is the worst case scenario? Maybe you got a runaway heater cartridge. We threw a 60 watt in there, and your runaway heater cartridge overwhelms your fan. It breaks, so you have only passive cooling. You don't have control anymore, and if it just keeps ramping up forever, what happens? And so we mounted it with a PLA mount, and didn't melt the mount, didn't break the mount. So
that's
you wouldn't
impressive.
Cause a fire in your worst case scenario, because it's not going to go anywhere. Yeah,
that's great.
Exactly.
And then we had talked, so you have 5 different mounting options on this.
Right, we do.
So there's lots of ways people can get this mounted on their existing 3D printers.
Yes, exactly. Yeah. So there's a threaded hole pattern on top. There's a through hole pattern on top. We got 2 different options from either side of the heat sink. And then for Delta printers, we've got a threaded pattern on here, so you could just mount in your carriage just like that. So the idea is we want to be able to be modular and adapt to pretty much any printer out there.
Yeah, that's fantastic. And then the last thing I wanted to mention was we had talked about, I just forget now, Oh, is it 1.75 millimeter or 3? Or are we doing both?
Yeah. So this is 1.75. We are experimenting with a 3 millimeter filament. We haven't seen the demand for that yet.
Most printers are 1.75, right, so.
Right. Yeah, so if the demand comes up, we can easily switch over to. We've built prototypes. We've given one to Printed Solid.
Yeah, I'd be interested to see this on like an Ultimaker. You know,
I would love to see it in an Ultimaker.
Again, everyone's E3D right now, and the only option for an all metal on a stock like CR10 is a micro Swiss. So being able to adapt something like this for those different printers would be fantastic.
Yeah, absolutely. Yeah, that's the goal, is to be able to get it on any printer you can.
Yeah. So like I said, I was so interested in this just because there are so few companies out there actually doing hot ends for 3D printers. You have your basic MKs, you've got E3D, and you've got micro Swiss. That's basically it of the big contenders. Yeah, there's a few out there, but no one big named.
Right.
You know, so to see something new like this come up is very interesting to see.
Yeah.
So thank you for taking the time. You know, I'm interested to see this, and I'd like to see some stuff in the future from you.
Yeah, awesome. We're excited.
Thank you.
Nice to meet you, man.